let's take a look at your MT7 LT4 seminar on solvent systems by multiplication. First thing I want you to do is do the first 5 questions on the video and then come back and we'll do the rest together. When you solve a system by elimination, we're going to eliminate one of our variables. Yesterday, we just added and subtracted, but you might have noticed what happens if the coefficients aren't the same number. Well, here's what we're going to do. We are going to multiply to make them the same number. We're going to find the least common multiple, just like you do with fractions. Then we're going to go through the same system or steps like we did yesterday. So let's take a look at example 1 here. Notice none of my variables are the same, but I see the y's have a positive and a negative. If I have a positive and a negative, I think that's the one I want to get rid of. So I look at 5 and 3, and you think, what is my least common multiple? Well, that would be 15, wouldn't it? So I'm going to multiply the first equation by 3, because 3 times 5 is 15. The second equation by 5, because negative 3 times 5 is negative 15. When I say the whole thing, I mean the whole thing. So 10 times 3 is 30x plus 15y equals 3 times 30 is 90. Then we'll multiply the second equation by 5. So I get 25x minus 15y equals negative 35. Now add my equations up. 30 plus 25 is 55x. My y's, they make 0, don't they? And then 90 minus 35, well, that's 55, isn't it? So this turns out to be pretty darn nice. X equals 1. Now I can use any of my 4 equations that I did to find y. I think I'll use my second equation here, or my first equation. So I'll say 10 times 1 plus 5y equals 30. Or 10 plus 5y equals 30. Well, let's subtract 10 from both sides. 5y equals 20. Divide by 5. Y equals 4. I'll write my solution as an ordered pair because it's actually where they intersect. And you get 1 and 4. And that's our answer. Let's do another one together. On this one, I notice my x's are opposite signs. So I think I'll get rid of that. The least common multiple of 3 and negative 2, or 3 and 2 is 6. So I multiply the first equation by 2. That gives me 6. And my second equation by 3, that gives me negative 6. So let's go through that. So 3 times 2 is 6x plus 8y equals negative 44. We'll get negative 6x plus 9y equals negative 24. Notice my 6x's, they cancel out. 6x minus 6x is 0. 8 plus 9, well, that's 17y equals negative 68. Divide both sides by 17. And y is going to be negative 4. Now let's substitute that into one of our equations. Let's do the first one. So go 3x plus 4 times negative 4 equals negative 22. And we'll get 3x minus 16 equals negative 22. So we'll end up adding 16 to both sides. And we'll get 3x equals negative 6. I'll divide by 3. X is negative 2. So get negative 2, negative 4. And there's our answer. Let's take a look at an application problem and kind of generalize this out to what we're going to do. So we have Hannah's comic book collection consists of a single issue that costs $4 each and a paperback collection that costs $12 each. She has 100 books in all. Her collection costs $616. Write and solve a system of equations to determine how many single issues and paperbacks she has in her collection. So first let's write our let statement. So I'm going to let X be the number of single issues. I'll let Y be the number of paperbacks. Now, when you have a system like this, usually you're going to have one equation for the total. And that's what we have here. She has 100 books. So X plus Y equals 100. And then we're going to write 1 using the money or something else. In this case, we have money. We know single issues cost $4 each. So I'll go 4x. Paperbacks cost $12 each, plus 12y. And then her total is 616. I can get rid of whatever letter I want. I'm going to get rid of x. Now notice this time they're not opposites, so I'll have to make one of them a negative. My least common multiple, though, is just 4, isn't it? So I think what I'll do is I'll multiply my top equation by 4. Now if I multiply by 4, they'll be the same, won't they? So I'll make this a negative 4. So if I multiply the first equation by negative 4, I'll get negative 4x minus 4y equals negative 100. I don't have to multiply my second equation by anything because now they're going to cancel, so I'll just copy that down. Now, we'll add them up. And notice, once again, my x's, they cancel. Negative 4y plus 12y equals 8y. 8y equals 516. So then I'll divide both sides by 8. This will be the number of paperbacks she has. So if we take 516 and we divide it by 8, did I make a mistake here? 616 minus 100 is 516. 12 minus 4 is 8, isn't it? Because I'm getting a decimal on my calculator. And there's no way I should be getting a decimal here. So let me go back here and see if I can find my mistake. Negative 4x minus 4y equals negative 400. Hello. There's my mistake. Sorry about that. So 400, 616 minus 400 is 216. We'll divide that by 8. So 216 divided by 8 gives me 27 comic books. Made this. Don't know what I was thinking there, but I made the mistake. Okay, now we can use that to find the number of single issues. I'll use my first equation, so I'll say x plus 27 equals 100. So I'll minus 27 from both sides. And x then is 100 minus 27 is 73. So we'll say Hannah has 73 single issues. And 27 paperbacks. And there's your answer.